Standard threads start with a high load on the first thread that quickly drops. That is why nuts are so short. Making them longer does not add much. The wave thread is radically different. It evenly distributes stress, reducing the load per thread. This is how it can be 25% stronger. This is a destructive test comparing the standard UNC thread with the wave thread. They have a high surface resolution by design and 3D printed using a plastic and carbon fiber material. The goal was to make the best possible parts at the limits of the 3D printer. They are being pulled apart at a constant rate. The UNC model breaks on the first thread, which is typical of all standard nuts and bolts. That is where stress is concentrated. The wave thread lasts longer because it evenly distributes the stress, but it is stretching more. This last graph is the load versus elongation from multiple tests. What is apparent is that the wave thread loads have a ceiling. They are not reaching the 25% more strength. That will take a stronger material. This is a 7/8 aluminum bolt with a wave thread machined into it. I had to write a software system that could take a wave thread and create multiple tool paths using 4-axis G-code to machine it. The problem is machining the internal wave thread. This nut is 3D printed. It's not practical to fit the tooling inside that could match such a complex surface. After all this, I had to come to terms with the reality that the wave thread may not be profitable. That is why I've changed directions from 3D print data to making a hard product, the keyed brick. Thank you.